So today I'll present, some stuff based on the paper that we published for Pablo's special issue. And this paper, which has the same title you see here, is was used as the discussion of my thesis. All right. So getting started, ruminants evolved in unmanaged, or what you could call natural landscapes. And these landscapes contain thousands of different plant species that changed based on season and climate and across different scales. So these, wide range of different species provided a wide arrangement of different plant chemicals, which could have different biochemical activities in the animal, but also different flavor profiles as well. And in these landscapes, animals were allowed or able to make choices on which food they selected at which time in order to meet either their preference at that time, which could be influenced by nutrient imbalance, or just because they wanted to, and it allowed them to have a lot of control over their environment. So this could be seen some places in the U.S. So these three pictures here were taken in Oklahoma during my master's. I did my master's at Oklahoma State University, but these three paddocks were never broken out into farmland, and never fertilized or had any real human intervention other than grazing. So it would be in location, or I guess it would be termed tall grass prairie. And so maybe it could be, equated to that as well. So this was actually taken in early spring, very high or relatively high quality pasture, about the highest quality that this area will have at the time. And this is the same pasture taken later that August in a different experiment. And we were measuring methane emissions using the green feed during these experiments. But here I found it very interesting that these animals were selecting for Ceresia lespedeza, which is supposed to be a kind of a noxious weed. And a lot of research in Oklahoma has focused on how to remove that. But obviously these animals, and I saw it even before I started my PhD, these animals were selecting this plant for a reason. Similarly, here in this bottom picture, this was taken in western Oklahoma. And Oklahoma is kind of unique because it goes from the wet east, where they get relatively a lot of rainfall, to the more arid west. And so Oklahoma is kind of a transition state. Here in the tall grass prairie, they get a little bit more rain than they do here in western Oklahoma. But this would be termed more short grass prairie or mid grass prairie, and it's got a lot of different forbs as well. So you can see different sagebrushes here. And similarly, we saw animals, these red Angus here, selecting and consuming sagebrush, and depending on different times of the year or different times of the day even. However, a lot of the systems, across the world have been intensifying, and they've either been, in pasture situations, monocultures, or simple mixtures of forage species, or in, especially in the U.S. and I guess some places in Australia, they'll feed, mixed rations. And both of these systems really provide monotony, a monotonous diet through time, right? It inhibits choice from those animals, but this is done because it simplifies management. You can have relatively high production rates, and they're easier to scale as well. So here, this is a dairy taken from Google Earth in the panhandle of Texas. So these cows are confined, fed, and brought to the milking parlor here, and that's their life, right? And this is a Dimmitt feed yard, which my family actually has some history of finishing cattle out here. But Similarly, these animals have high stalking densities, right? And also the stalking density equals the stalking rate, because that's where the animal, lives for that 100 to 150 days that it's on feed. Here, also taken from Google Earth, kind of by Rakaya there in Canterbury, not too far from where I did my PhD and where Lincoln University is. I don't know how many dairies are here, but you can see how homogeneous the landscape is. And the majority of these dairies would be based on ryegrass white clover, right? And interestingly, whenever you look at the stalking densities between these two systems and this system, they're basically identical. Obviously, down in the grazing situation, that would depend on how much forage is available at that given time. But let's say there's 3,500 kgs of dry matter a hectare, and you're wanting to leave a target of 1,500 kilograms of dry matter per hectare as a target residual. You would have about 8 meters to 10 meters per head allocated per head per day. And that's the same as what you see here in these West Texas intensively managed areas. So the modern production systems have led to, it's kind of, we've reached where we're faced with doom and gloom, right? We have different societal pressures, but producers still have to meet economic demand so that they can make a living. Society is concerned with animal well-being and welfare. The producer has to maintain animal productivity or improve it so that they can stay economically viable. But also they need to address environmental impacts and environmental concerns through nutrient excretions like methane or urine nitrogen. And then also the producer is concerned with the healthfulness or how healthy the end products are, what the products that they're consuming, but also the quality. So what kind of eating experience will they have when they consume these products? So you see a lot of this in scientific works and also in popular press, where people are writing papers, publications on how to reduce meat intake that benefits human health and planet health, right? Here, the Eat Lancet diet says that we should be eating very little animal-sourced foods. And of that animal-sourced food, even less of that should come from beef or lamb, right? From ruminant products. So, and with environmental concerns, there's also concern with how does these environmental impacts affect human health. And a recent study, and which was reported here in this popular press article, reported that air quality causes 18,000 deaths in the U.S. annually, and all of that would be from ammonia emissions in the confined feeding system. So about 50% of ingested nitrogen is emitted as ammonia, volatilized as ammonia in those production settings. And then I saw this article here, and I thought it was funny where, this writer claims that even though the planet is dying, we will not stop eating meat as Americans. And I think you kind of see that globally too, where meat consumption is on the rise. So the problems that we're facing as an industry and that our producers are facing are multifaceted, and there are multiple levels that we need to address, or goals we need to try to attain. And I think this really lends itself to being thought about through the lens of design theory, which a lot of other scientific enterprises would follow the design theory framework. And I took this one from information systems paper. And I thought that it provided a very neat conceptual framework to address these multiple problems that we're facing as an industry. So it starts out by identifying your meta requirements. And so that's really what goals or what problems are we trying to address. And then as the designer, we need to think about the kernel theories, what they term kernel theories. And these are theories or established works through experiments that we can implement to address the meta requirements. And once you understand kind of the experimental knowledge that's out there, you can really start to implement a design. And they term this a meta design. And so the word meta in requirements and design, that word meta is because it's not one single requirement or goal that we're trying to address, but it's a cluster of problems. And at the end, we would end up with a product that was, produced through our design that we can test to ensure that it addresses the meta requirements that we outlined. So in our context, we identified in the paper, in my thesis, we identified 5 meta requirements that we believe has to be addressed by the ruminant livestock industry. Chiefly, we need to enhance animal welfare, because with poor animal welfare or negative animal welfare, we kind of lose our social license to farm. The second one that we decided to address would be to improve animal performance, because if the producer is not economically viable, then he's going to go out of business and cannot maintain or produce his product. And thirdly, the reducing environmental impact is important to society. We need to improve product quality and also human health after they consume products from ruminants. And if we can't have animals that utilize our functional dietary diversity or won't ingest the foodscapes that we designed for them, then we can't address these other goals. So we had that as our 5th meta requirement. So some of the kernel theories would include the hedonic and eudaimonic theories of well-being, which I'll explain, I believe, in the next slide. And that would be to address the requirement 1 of animal welfare, different complexations of plant secondary compounds, minimal total discomfort theory of intake, and post-ingestive feedback theories of intake in order to improve animal performance. Using plant pharmacology and the plant secondary compounds environmental remediation, and also sustainable intensification, so increasing performance to reduce environmental impacts. And then the nutraceutical and biochemical richness that you achieve by providing a diverse diet, that would improve product quality and also the safety once humans consume this. And finally, that early life experience and fetal programming could design the animals to prefer or to actually incorporate the designed foodscape that we developed. So that leads us to our meta design, which is if you provide dietary taxonomics, so different species, but also plant secondary compound diversity, that you can address the different meta requirements outlined. And at the end, we would have a testable product. Producers could produce a testable product, which we can test to see if we would fulfill the meta requirements. So well-being, just kind of diving in, I guess the first one, well-being and welfare are often used interchangeably. However, we and some others would separate the two words, and we define well-being as the mental state of the animal. And so that comes from, different emotions and the subjective interpretation of the animal's experience. And then welfare is the actual animal state as a whole. So this would include well-being, but also things like health and their experiences with their environment, including their feeding environment. So in 340 BC, Aristotle wrote the Nicomachean, and here he defined hedonic well-being and eudaimonic well-being. So hedonic well-being is, that word is derived from the same word as hedonism, right? So this is happiness through pleasure. And this is really a balance between positive and negative affective state. He subsequently defined eudaimonic well-being as happiness through pursuit of one's telos, which telos is defined as one's given purpose. So Aristotle said, not only should we pursue happiness through, through pleasure, but also by achieving our goals. And telos in animals has been identified as being genetically encoded. In that book, Aristotle claimed that happiness solely through pleasure is only suited for the life of cattle, right? Implying that if humans purely tried to be happy through hedonic well-being, then they are livestock, right? But I would argue with Aristotle, not that it would do me any good, I guess, but I would argue with Aristotle that even cattle have a sense of eudaimonic well-being, and so that happiness solely derived from hedonic pleasure is also not suited for cattle. So we hypothesize that providing a diverse diet, we can enhance animal well-being through hedonic well-being, and so that's through pleasure, right? But hedonic well-being could be increased through oral sensorial stimulation, and also allowing the animal to better attain nutrients to meet their individual requirements. When these nutrient requirements are achieved, the animal will be in a more positive internal state. And then also, we hypothesize that animals can achieve eudaimonic well-being through dietary diversity. And this allows them, to control their environment and display individuality and make choices, and therefore, in a sense, pursue their telos, which is, as I said, pursuing one's purpose or consciously making choices and controlling your own environment. So we believe that dietary diversity can improve animal performance as well. So we know that when animals are less stressed and happier, they are more efficient. And so therefore increasing their well-being through the mechanisms outlined previously, we believe that you would have more efficient animals, more efficient with their nutrients. Also, dietary diversity has been shown to increase intake, and reduce food weariness. So food weariness is where the animal consumes the same food and the same flavor profile over time, and they basically get sick of it. So providing oral sensorial stimulation may increase intake, and therefore increase energy intake and result in increased performance. Now, as I mentioned before, the animals should be able to better meet their individual requirements through choice, using their nutritional wisdom. And this is important because, here's the normal distribution curve, right? The bell curve. If we assume that, and this line is that if we assume that nutrient requirements, and this could be, assumed for all nutrient requirements, are normally distributed across individual animal. And if this is the mean of the animal, there'd be very few animals that would fall right on this line. So about 50% of animals would be underfed a specific nutrient to meet their requirements, and about 50% would be overfed to meet their requirements. Overfeeding nutrients can cost energy as they remove that additional energy, right? I believe Gary Waghorn in a book stated that about 4% of ME intake and this was done in sheep, about 4% of ME intake is needed to remove excess nitrogen by converting ammonia to urea in the liver and therefore excreted in the urine, right? And then obviously underfeeding nutrients will result in less performance because they just have less to catabolize or anabolize. And then finally, by providing dietary diversity and a diverse arrangement of plants with a wide arrangement of different plant secondary compounds, and these plant secondary compounds can influence nutrient use efficiency. Just one example, tannins, they bind nitrogenous compounds in the rumen, and they can manipulate site and extent of protein digestion. So they shift it from being fermented in the rumen to more bypass protein. And several experiments have shown where high tannin containing plants can actually improve animal performance by increasing bypass protein. So next, dietary diversity, we speculate can reduce environmental impacts. As we mentioned, it increases performance, and this would reduce emission intensity, where emission intensity is the kilograms of CO2 equivalent per unit of product produced. We had mentioned again that you would increase nutrient use efficiency, and this would result in reductions in nutrient excretions. So if the animal is excreting urine nitrogen, that nitrogen is either volatilized as ammonia, emitted as nitrous oxide, or leached through nitrate leaching. All of those have negative impacts on the environment. And then plant secondary compounds can directly reduce greenhouse gas emissions of livestock as well. So we talked about it before, but tannins can shift the nitrogen excretion from urine to feces and provide the benefits, the environmental benefits or protection mentioned previously with reducing urine nitrogen excretion. But they can also directly inhibit archaea bacteria, which these are the methanogenic bacteria in the rumen. Another example would be saponins. So saponins, they're a class of compounds which can inhibit protozoa. So these protozoa are they are a big source of hydrogen emission or hydrogen production in the rumen. And the methanogenic bacteria, which convert that hydrogen into methane, actually are known to associate closely to that protozoa. So if you can reduce the number of protozoa in the rumen, you would expect to see a reduction in methane as well. So getting into how dietary diversity can enhance human health. Often the health effects of meat and milk have been associated with different fatty acids, where polyunsaturated fatty acids and conjugated linoleic acid are considered to be healthy, and saturated fatty acids are considered to be unhealthy. So despite the ruminants consuming plant-based feeds being high in polyunsaturated fatty acids, due to biohydrogenation, a lot of those unsaturated fatty acids are converted to saturated fatty acids. And so ruminant products have are known to be a large source of saturated fatty acids and have been associated, and saturated fatty acids have been associated with different heart health and other negative health effects. However, this belief is contested, and the health benefits, the nutraceutical benefits to humans of polyunsaturated fatty acids have been debated and inconsistent. But we know that when we increase the biodiversity and include plants like chicory and plantain, which have a shorter time, spend a shorter time in the rumen and have a greater rate of passage, and therefore the fatty acids provided in the chicory and plantain undergo less biohydrogenation. These plants like this will increase polyunsaturated fatty acid content of meat and milk. And then plant secondary compounds are known antioxidants. Tannins are polyphenols, and Phenolic compounds are very, very strong antioxidants. And by feeding these plant secondary compounds, we see a subsequent increase in antioxidant capacity of meat and milk. So this greater antioxidant capacity of these end products would reduce the byproducts produced by oxidation reactions. And these byproducts produced by oxidation reactions are often pro-inflammatory. Examples of these would be isoprostanes. So isoprostanes are formed by arachidonic acid oxidation, and they act as a prostaglandin analog, and prostaglandins and these isoprostanes will bind to the same receptors of prostaglandins, and the prostaglandins cause an inflammatory response. Another example would be melanoidal aldehyde, which is a byproduct of lipid peroxidation. And then also meat with greater antioxidant capacity have been shown to have greater shelf life, color stability, and water holding capacity. And so the greater water holding capacity would make that meat juicier after it was cooked. And water holding capacity has been shown to increase the eating experience and the eating quality to the end consumer. And then finally, as we had outlined previously, by increasing or reducing stress of these animals and increasing positive well-being, there's strong evidence that these animals could have higher quality or could produce higher quality products, as a stressed animal would have lower quality meat and milk. Addressing the final strategy to increase, or addressing the final meta requirement we have, which is how do we rapidly adapt animals to utilize our design or a design diverse landscape. So ruminants have been shown to exhibit significant amount of dietary neophobia, and this has been shown in all ages and all species of animals, and also to all different diet types, including novel or new forages, supplements, and mixed rations. So if we want to see the benefits or the potential benefits of a diverse diet in the animals, we need to rapidly adapt these animals to incorporate and to fully utilize their designed foodscape. So animals can gain dietary experience chiefly through experiences with their dam. And these include in utero, there's known flavor receptors that the fetus has, and this appears to be most strong in the last third of gestation, where if the dam is fed components of a plant or the actual plants in the last third of gestation, their offspring, even if they don't have any direct experience to this plant, will have a greater preference for that species than their unexperienced counterpart. They also can gain, offspring can also gain different experience to flavors through their mom's or through their dam's milk. And then finally, through observing their dam. It's known also that their cohorts, by observing their cohorts and seeing them eat or consume a different species or a novel species of plant, they'll also gain experience and will be more quick to incorporate that novel feedstuff into their diet. However, the effect of observing their cohorts is much less than the effect of them observing their dams. And then the final way they gain experience is just merely through repeated exposure over time. However, this takes time. So if we can utilize these other pathways, then maybe we can more rapidly adapt these animals and increase their acceptability of plants which contain either unfamiliar flavors, but also some of these plant secondary compounds are known to have off-putting flavors, like tannins can be bitter, and so the animals will be less willing to consume that bitter flavor. However, if we can give them experience to that, maybe we can increase and rapidly adapt these animals to consume these unfamiliar or off-putting flavors, and therefore subsequently benefit from the the beneficial effects of the plant secondary compounds. So in conclusion, based on our design, we could produce end products which can be tested to see how they address our meta requirements. So by achieving the different meta requirements, we can improve the animal's hedonic and eudaimonic well-being and provide them with a life worth living, and getting away from merely providing them the absence of negative welfare. We can also improve our hedonic and eudaimonic well-being. So consumers, when they buy a product, the obvious reason they would buy a product is for utilitarian reasons, right? Let's say a consumer wants and they need a hammer, so they will go to the store to buy a hammer. Or if the consumer wants to make something for dinner which requires hamburger meat, they will go to the store to buy hamburger meat. So that's solely the drive for that consumer to buy that product is for utility reasons. However, consumers also are known to be influenced based on hedonic purposes. So they will pay more money for a higher quality end product if they believe that it will give them a greater eating experience. And the greater eating experience could just be perception. For example, McDonald's has the Angus burger, which they sell to the consumers at a premium. So the meat is ground up as just like the other hamburger meat, and it is, let's say 80% lean, 20% fat. So would the eating experience of the Angus burger be any different from the traditional McDonald's hamburger? I would say probably not. However, through that perception and through their marketing of these Angus sourced meats, they're willing to pay more money for that. And as we're seeing more socially conscious consumers here recently, we're learning that consumers are also willing to increase and make purchasing decisions based on eudaimonic drivers. So they will spend more money if it's associated with improved welfare. And you see that with cage-free eggs versus the traditional caged eggs. Even though the cage-free eggs are more costly by at very least 50%, maybe 100%, they're willing to spend that money because of perceived improved animal welfare conditions for that animal. And also you're kind of seeing where products are being marketed for reduced environmental impacts as well. And that would, if the consumer is willing to pay a premium for reduced environmental impacts, then that could also be considered a eudaimonic driver for behind that purchase. And then finally, by design, you can increase and provide additional income to producers. This can be done through increased animal performance, like we'd mentioned, but also if we can address these hedonic and eudaimonic drivers of purchasing for consumers, can we get these producers some premiums for the products that they produce? So some limitations of this experiment, this review. We obviously cannot design what functional dietary diversity means for every climatic and production condition. However, if producers use these concepts and they can use design as a conceptual framework, they can design their own landscapes to provide foodscapes for the animals and then subsequently to us. So for something to be functional, it must be context dependent. And these contexts include environmental and climatic conditions, topographical, what production setting they have, such as their animal species and that animal species' physiological needs. And also there's the context of cultural and societal and political considerations that producers need to consider. So with that, I'll take any questions.
Thanks for that, Matt. It's super interesting. I've actually read this paper and I just think it's really great, and I'd recommend anyone to read it if they're interested. It's really fascinating. Um, so I do have a few questions for you. I'll start it off, and then if anyone wants to raise their hand or jump in, they're more than welcome. The first one I just sort of wanted to, I know in your sort of framework that you put together, the final part, coming up with strategies that sort of achieve these sort of goals that you've got, you actually looked at, well, your PhD research sort of looked at how to do that. Do you have any comment on like what you found throughout your PhD work that sort of proves your hypothesis that you've come up here? Or
Yep. So we found in one experiment, and it's actually here on this question slide, oops, but here in this picture, we were looking at the preference of these lambs. And so we were doing observations where we saw which forage species they selected. So here we had lucerne, chicory, ryegrass, plantain, and we attempted to sow dock, broadleaf dock. So I may be the only person in the world that has taken dock seed and put it through a drill. Maybe not, but and
certainly
what
in
we
New
found
Zealand,
was, yeah. So what we'd found was that if the animals had previous experience to these, and in one experiment, we actually provided the experience directly to the lambs. And the other experiment the next year, where we grazed lambs in these same paddocks, we found that just providing it to their dams, the experience to their dams, altered their preference. And we saw it namely with an increased preference for chicory and a tendency for an increased preference in plantain. However, as the experiment went on, because we observed them for 7 weeks, as the experiment went on, we saw the differences between these animals with different experiences change to where they were very similar, basically the exact same by week 7. We followed these lambs both years through finishing. And the first year we slaughtered basically one from each replicated paddock in the diverse strips. And then we also had sheep that were, in the first year, they were grazing annual ryegrass. And in the second year, they were grazing perennial ryegrass with about 15% white clover. And we found that in the first year, compared to the annual ryegrass only, the lambs had about 80% greater average daily gain, and subsequently greater hot carcass weights. And in the second year, we found a 30% increase in average daily gain for the lambs that were grazed on these, the diverse arrangement of species. Those meat samples are waiting to be further analyzed to look at the quality of the meat in terms of the fatty acid profile, and we're looking at doing maybe metabolomics on those eventually. But yes, those would be 2 examples that I found directly in my experiments.
yeah, and so with the pre-gestational exposure, do you think like that the differences in live weight gain and stuff that you saw post lambing, was that like related to neophobia, or do you think it's sort of something that's actually going on in utero?
So because we looked at that, including that as a factor, their early experience or their in utero experience, and how that influenced their performance later in life. And we didn't find anything significant. And I think a lot of that would be because of the animal's capability to learn throughout the experiment. So even if and we were forcing these animals to clean the break basically before we gave them a new break. And so what would have happened if we turned these animals out into an extensive rangeland and the animals weren't forced to consume a particular species, would they have gotten that same experience, and would we have seen differences in average daily gain? I'm not sure, but potentially.
It's interesting though, because it does sort of show that even with that in utero experience, animals are still able to sort of compensate from, during that sort of early life, I guess. I also wanted to ask you, and I apologize, it's a little bit philosophical, but how do you think we actually go about measuring eudaimonic pleasure in animals and, coming up or sort of engaging producers to think about the well-being, I guess, instead of just welfare of their livestock?
Mm-hmm.
And do you think this is going to change like government regulation of welfare? So, for example, in New Zealand at the moment, we have the Animal Welfare Act of 1999 is kind of the what's used, and that involves the 5 freedoms, which I think you're familiar with. Do you think that sort of thinking will change or could change how we actually define animal welfare?
So I think doing dietary experiments and seeing if that improves their well-being will be hard to tease out the difference between hedonic and eudaimonic well-being. So I think any experiments that would identify eudaimonic well-being in particular would need to be done on using methods that don't include the diet necessarily, right? Several experiments have shown that animals that are allowed to choose which pen they go to, they have greater or lower cortisol levels in their blood as an indicator of stress, and exhibit less, stressed behavior than animals that are confined to one pen, even if that total area allocated to that animal is the exact same. Animals that when they are, so one experiment, they had a bunk which the animal could go to for a reward. So the animal that walked it, so they had one treatment where the animal could just walk up to the bunk and receive the reward. And in the other treatment, the animal had to perform a task. And these were done with heifers, I think. And the animal that performed the task had exhibited greater pleasure or greater reward response through their behavior than the ones who just got the reward freely. So I believe there is evidence to support eudaimonic well-being in animals. Humans are one big evidence of that, right? Because you could work all day and achieve your goals, be stressed out, but in the long-term happiness, you're ahead, right?
Yeah, that's fascinating. So I see that Philip, you have your hand raised. Do you want to ask Matt a question?
Sure. Oh, hi, Matt. Thanks very much for an excellent talk. It's very fascinating. I was just in the sort of commercialization aspect of what you're seeing here, and just how practical it is to really have, quite diverse pastures, I suppose, for animals to graze. And do you have any comments around how you might see that playing out? Is it easy to just plant a multi, just mix seed up and plant it out in the paddock, or do you need to sort of break it into these breaks like you've done for your experiment sort of approach? Thank you.
So that's a good question. I know some people have looked at what degree of separation can you have these species, and the animals can actually make a choice. And I think for cows, it was shown to be at 3 feet separated, or whatever, 3 inches, excuse me. I think it might be inches, whatever scale. The cows were able to actually choose between different species. However, since cows whip that tongue out and grab a huge bite, a clump of forages, and to acquire that prehension, if the species is mixed, they may not be able to choose which species they eat at a given time. So the belief is that in a mixture, even though you could have a greater biodiversity in the landscape, you're still inhibiting choice, and maybe that animal is having still a monotonous diet at that given time. Kana has done an experiment where we physically hand mixed different different forages, and then we had those same forages that were fed in separate bunks, and the animals that had choice through those separate bunks had greater performance than the ones provided the mix. And this was done in lambs. And we did botanical composition of the diets. Correct me if I'm wrong, Kana, but we did botanical composition of the different diets throughout the day. So to confirm basically that the mixed diet, the animals couldn't sort through the mixed diet and identify particular plant species.
Yeah, that's fascinating. So really sort of separate zones would be the way to go, which probably makes it marginally easier for a farmer to manage too, I guess.
Yep, definitely.
Oh, great. Thank you.
Well, thank you.
Nicholas Tyler, do you have a question?
Matt, that was a wonderful talk, and I agreed with everything you said. So there's not much to ask about, but I had two thoughts.
Yes,
The
sir.
first is this business of in utero imprinting on diet selection. Now, I work with reindeer, and reindeer are pregnant in winter, and they are born in early summer. So the calf in its first 4 months of life does not experience anything that its mother has eaten in wintertime, because her diet is entirely different. I wonder, would you care to speculate? You probably have no grounds, but could you speculate anyway, to what extent you think in utero printing in gestation in an animal like that could actually carry over to 6 months hence, when the calf first experiences what its mother ate when it was in utero? That's my first question. And then my second question is completely unrelated, but are there comparable data to what you have described to humans? Humans are mammals just like cattle. Is it the case that if you give isoenergetic diets to humans, in one case, a completely monotonous diet, but in another case, a diverse diet, humans actually increase their energy intake? Are there data like that? They are two questions completely unrelated.
All right, you'll have to help me make sure I don't skip one. So in the first instance, I believe that Provenza and I'm drawing a blank, starts with a W of the first author's name, but they fed cows a high fiber diet when they're gestating. And I think it was ammoniated wheat straw was the diet that they fed. And then they offered their offspring that high fiber diet later in life, like 6 months later or something, right. when they're weaned, so much later. And they still had a greater preference for that and had greater NDF intake than their inexperienced cohorts at that time. For reindeer, I'm not just super sure, I guess, but I believe that there would be evidence in other species that would suggest that knowledge is retained for some time. But I guess reindeer would they have more of a monotonous diet if they're consuming the what is that up there?
Well, they eat a lot of lichen in winter, and the plants they eat are the same plants they feed on in summer, but they are at a completely different life stage.
Okay.
But I think the experiment you've just quoted is an excellent example, suggesting that yes, indeed, there is long-term memory. And what about humans on an isoenergetic diet? Does diversity increase intake? Are there data for that?
So, and I'm getting this reference, I didn't end up hunting down the paper myself, but I'm getting this reference from, again, one of Dr. Provenza's review papers, where they incorporated in soup different spices versus a soup that just was salt, I guess. And the soup with different spices actually, I think they actually satiated themselves quicker on that than they did the bland soup. And I guess they were kind of Dr. Provenza was using that as an example of how plant secondary compounds can help address the human obesity problem. But I don't know for a fact if providing humans that kind of choice would increase intake, but colloquially, I do know that whenever I go to a buffet, I sure eat a lot more than than I do when I'm just getting a plate.
Excellent. Excellent. Thank you very much.
Oh, thank you, sir.
Well, I was just wondering, you mentioned at the beginning of your presentation, talked a lot about the doom and gloom narrative that sort of surrounds agriculture, animal protein production at the moment. And I guess one of the themes that's sort of coming from these workshop series is that may be true, but agriculture also provides a lot of essential ecosystem services that we actually rely on. And I guess I just wonder, from your perspective, what do you think the future of the meat industry, any animal protein sort of industry is, and how much do you think that dietary diversity can actually be used to sort of meet the current environmental challenges that we face?
Yep. For sure in pastoral systems, I believe there is a good opportunity to increase the diversity that we feed to animals. I know here in the U.S., all the different societies like Dairy Innovations, and which is they basically get checkoff dollars, I guess similar to Dairy NZ over there, where they get a portion of each dollar of milk sold. They've called for their producers to be not carbon neutral, but carbon negative. And I find that to be I would say maybe not unachievable, but would be very hard to do in their confined settings that are here in the U.S. without using you have to have some way of capturing carbon, right? So they're going to have to integrate more live, I guess, cropping systems and change their management of how they grow different crops. And something I was actually interested in doing in my at my new position is looking at incorporating things like plantain, where they have this root exudate that inhibits nitrogen dynamics in the soil or slows it down, but it basically reduces nitrate leaching and at the soil level. So can we incorporate some of these different ideas that are happening abroad, like in New Zealand, into the different production systems here in the U.S. in order to help manage some of our nutrient or manure issues that we face? And I think using different plants like that would be an important means of doing that. But for sure in pastoral systems, I think animals are going to need to be provided a diverse diet. And I think there's going to be a lot of economic incentive to do that, especially if a company develops almost like a checkoff, or not a checkoff,
some form of like a regulation or a premium or something.
Yep. Like almost like a certification.
Yeah. It's really interesting. It kind of touches on to what we were talking about in the previous session with Professor Taub, and even with the introduction of government sort of regulation and benefits as well, economic benefits. we're still seeing producers are actually starting to make decisions and change their systems on their own back just to meet the demands of society pretty much, which is really, and we certainly see it here in New Zealand where we're not subsidised at all, and farmers are actually really actively looking for options to try and sort of improve what they're doing.